String functions enable efficient manipulation and transformation of text data. In PySpark, there are built-in string methods within the functions module, and I'll demonstrate some simple examples. So in my Databricks notebook, I've created a simple data frame consisting of city names and state codes. It contains improperly formatted strings. They have inconsistent casing, some are in proper case, some are in lowercase, as well as leading and trailing white spaces. I'll perform some data cleaning using some basic string functions. So the first thing to note from the output data frame is that the values in both columns contain leading and trailing white spaces. So we can remove them using the trim function. The trim function takes a column or string as an argument and removes the leading and trailing white spaces from the values in the column or the string. So let's import the trim function. So from PySpark.sql.functions, import trim. So from that data frame, I want to select, and then I will use the trim function on the city column, like so. And then I also want to use the trim function on the state column. And then I can display that. Now just note that I am using the string column name as the column reference. I could use a number of different ways to reference a column. I could import the col function and use that to create a column object, or I can also use indexing or data frame attribute access. So let's run this and see the results. And that seems to have worked. You can see that the leading and trailing white spaces appear to have gone. Now notice that the column names are actually just the expression. You might prefer this to be human readable, so you can actually alias the column names. So you can do .alias at the end of it, and then let's just call it city again. And this one we can do .alias and call it state. Now let's run this. So now we have given the columns a name. Let's also reassign this to the variable df, and then let's display that. df.display. So now we have actually stored the changes. So we have used the trim function to remove the leading and trailing white spaces from the data frame. So we've taken one step to cleaning the data. So now let's format the values to be in a consistent casing. I want the city to be in proper case, where the first letter of each word is in uppercase, like New York for example, but I want it to be the same for LA. Whereas I want every character in this state column to be in uppercase. So we can import the init cap and upper functions. So init cap takes a column as an argument, as you can see when I hover over it, and then it formats the value where it capitalizes the first character of each word. Upper just takes one parameter, which is a column, and it capitalizes each character. So let's do that. So I will do df, and actually I'll just reassign the result of this to the variable df. So it's fixed. So df.select init cap on city. And then I will do upper, or actually I'll alias this as well as city. And then I will do upper on state, and I'll alias that as state. And then I will do df.display. So let's run this. And as you can see, that's worked. Great. Now another useful string function is lit. Lit is a function that creates a column with a constant literal value, allowing you to add fixed values to data frame expressions. So let me demonstrate. So if I want a new column where every value is the same, then I can do the following. First, I need to import lit and then run this. And that's worked. And then what I will do is df.select. I'll select the city column. I'll select the state column. And then I will use the lit function. And let's just say I want every value in the lit column to contain some constant value, like so. And now let's do a display. So notice the result of this expression. the value is the same throughout. So this can have a number of use cases, and I'll demonstrate one momentarily with the next function. And the next function I want to talk about is the concat function. This concat function will concatenate two or more columns or expressions into a single column without any separator. So let's say I want a column that contains the city and the state combined. So then I could import concat. So let's go up and import concat. And just note, as a shortcut, if you want to import all of the functions, you can do from pyspark.sql.functions import star. But it's best practice to only import the functions that you need to use. So I will just specify them individually. So I'm importing concat now. So let me do df.select city, state, and then the result of the concatenation of city and state. So I've provided two columns as arguments, and I will alias this as city underscore state. Let me just format this better. And now I'll display. So that's worked, but the values are merged together without a separator. So I could add a separator using a lit function. So for example, let's say I want to separate with a comma and a space. So each value should be separated with a comma and a space. So I can actually just modify this to also add in between the lit function with the comma and the space separator. So now if I'd run this again, that's worked. So it's used this literal value as a separator. Now you would think that you could just specify the comma and the space like this, but PySpark would assume you are searching for a column and it would throw an error. It would say no column exists with this value, as you can see. So you need to use the lit function in this instance to specify this is a literal value. So that's where the lit function can come in handy. There's also another function called concat_ws. That function concatenates columns into a single string while inserting a specified delimiter between the values. So with this concat function, we needed to use this constant value as the separator, but we had to do this ourselves. So anytime we want to use a separator, we use this lit function. But the first argument in concat_ws is the separator. This can be passed in as a string without this lit function. So let me demonstrate. First, I will import concat_ws. And then I will do df.select. And again, I'll select city and state just for reference. And then I'll do concat_ws. And this time the first argument is the separator, which I want it to be a comma and a space. And then you specify the columns. So you can specify as many columns as you like. So I'll do city and state. And I'll alias that as city_state. And actually, let me reassign that to the variable df, and then I'll display that. So this way, we are fixing the changes into the variable df. Great. So here's the results. Now, one final function I want to demonstrate is length. This will return the number of characters in a string column, including spaces and special characters. Let's see the length of the values in this city state column. So first, let's import length. And then what I will do is df.select. I'll select city_state, and then I will also return the length of the values in that column by passing that in as an argument in length. And I'll just alias that as number of jars. And then I will do dot display. I've got a typo with length. And that's worked. But just note that this will return the number of characters, including white spaces and special characters, such as a comma. Great. So that was a basic introduction to string functions, with a demonstration of some of the more common applications. You can see the string functions in the official documentation here. Just navigate to the latest release, Python API docs, API reference, and then under Spark SQL, when you go to functions, on this side navigation, you can go to string functions. A lot of the functions I've described will be here. So here's concat_ws. So you can click into them, and then you can get the documentation such as the parameters they accept and what they return, with some examples. So please refer to this documentation for guidance if you have a specific use case that requires any of these functions. It's all clearly documented with examples and should be easy to follow.